Edexcel IAL Chemistry 2025 June, Unit 1, Question 23. This question is about structure and bonding. Ionic bonding occurs between metals and non-metals. Describe ionic bonding. So you can describe ionic bonding as electrostatic attraction forces between oppositely charged ions. Explain why the ionic bonding in magnesium fluoride might be expected to be stronger than ionic bonding in sodium fluoride. You can see the anion in both cases is fluoride. So we have to consider the cations, the polarizing power of cations. When it comes to magnesium ion, it is having a higher charge and a smaller size compared to sodium. So we can expect magnesium to more polarize the fluoride anion. Therefore, we can expect much stronger bonding in magnesium fluoride compared to sodium fluoride. Part 3, sodium and oxygen react to form sodium oxide, which is also ionic. Draw a dot cross diagram showing ions present in sodium oxide. So this is something that you have done in O levels. So we can end up with this kind of a diagram. Draw the ionic lattice for sodium chloride. You should show at least 9 ions alternatively arranged. Plus and minus, positive and negative ions should be included in your diagram, and at least 9 ions have to be included. Better if you can draw representing the sizes, like in this diagram, chloride ion is larger than sodium ion. Part B, nonmetal atoms join together using covalent bonds. Describe covalent bonding. Straight away from theory, you can describe it as electrostatic attraction forces between shared pairs of electrons and the nuclei of the atoms which are participating in the bonding. Methane, ammonia and water are covalently bonded compounds. Draw the dot and cross diagrams for molecules of methane, ammonia and water. This kind of questions you have done again in O levels also. So dot cross diagrams for methane, ammonia and water, showing only the last shell electrons. The three molecules, methane, ammonia and water, each have a different shape. Complete the table below with the shape and the bond angle. Even though the shape is same, shapes are different, they have the same number of electron pairs around them. Because of that, you get different bond angles. Methane is having a tetrahedral shape, whereas ammonia is having trigonal pyramid shape, and water is having an angular or V-shaped, it's a V-shaped molecule. Bond angle of methane is 109.5 or 110, ammonia 107, water 105. Yeah, you should have studied these things in the perspective lessons. Along with the bond angles, you should have an idea of these bond angle values. Explain the differences between molecular shapes and bond angles for ammonia and water. As I said, there are 4 electron pairs around the central atom of each case, methane, ammonia and water. Here you have to compare the bond angles of ammonia and water. According to VSEPR theory, we know the repulsion exerted on the other electron pairs by electron lone pairs and bonding pairs are different. So because of that, you get different bond angles. In ammonia, you have one lone pair, whereas on water, on oxygen of water, we have 2 lone pairs. So more repulsion is exerted on the bonding pairs, Therefore, the angle becomes the two bonding electron pairs become a little bit closer, causing the bond angle to be smaller. So you can say both ammonia and water have 4 electron pairs around the central atom. Ammonia have 3 bonding pairs and 1 lone pair. Water have 2 bonding pairs and 2 lone pairs. Lone pairs of electrons repel the other electron pairs more than bonding pairs, causing the bonds to be closer in water than ammonia according to VSEPR theory. Ethene and polyethylene have different melting temperatures. Explain why their melting temperatures are different. In ethene and polyethylene both, the intermolecular attraction forces are van der Waals interactions, van der Waals attraction forces. But when it comes to van der Waals attraction forces, we know when larger the electron cloud of a molecule, it is easier to distort. Therefore, the strength of van der Waals force increase in large molecules, even though in even though they are occurring in non-polar structures. Larger the molecule, you get more van der Waals attraction forces. That is what you have to stick to. In polyethylene, you can't talk about breaking the covalent bonds because it's not bond breaking, it's just you have to melt polyethylene, not break the bonds and make it into ethene. So you have to address the intermolecular attraction forces, the van der Waals forces. Metals are held together by metallic bonding. Describe metallic bonding. So you can describe the metallic bonding as electrostatic attraction forces between cations and electrons in the sea of electrons. And part 2 of that question, metals conduct electricity when solid. Explain with the aid of a diagram why copper conducts electricity. So they say use a diagram. So we'll first draw the diagram, a labeled diagram where you can see the electrons in the sea of electron and the cations. And then we will describe, as shown in the diagram, there are free to move electrons in metals like copper. And when you apply a potential gradient, these electrons are traveling in one direction, creating an electric current. So copper conducts electricity.